Questions 7 through 14. Question 7 says continuous random variable. Let's say a variable goes from 0 to 1. So let's say it's everything from 0 to 1. It could be any number between 0 and 1. What's the probability that is less than or equal to 0.49? What's the probability that's greater than or equal to 0.27? What's the probability that's between 0.27 and it says 1.27, but remember that should be between 0.27 and 1 because it can't be higher than 1. What's the probability that's between 0.1 and 0.2 or 0.8 and 0.9? What's the probability that's between 0.3 and 0.8? And then the last one is what's the probability that it equals 0.5? Well, if it's continuous, it can never equal just one number, so that one is 0. Now, the probability that's less than or equal to 0.49 is very simple. It's 0.49. So just think about it that way. And if you need to look in the back for a couple of those hints, that's fine, but it should just be 0 to 1. How much is it included in there? Okay, for number 8, you're going to use the formula 0.45 minus 0.4 divided by 0.023, and that formula is x minus the mean divided by the standard deviation. That will give you your z-score of a little bit more than 2. Then you'll do a normal CDF from that number to 999 to get the probability of it being over 45%. To get less than 35%, you'll set up the formula 0.35 minus 0.4 divided by the standard deviation of 0.023, and you'll get a negative z-score. And you'll do a normal CDF from negative 999 to that z-score. And then for C, you'll just do a normal CDF of the lower z-score to the higher z-score to get the part in the middle. For question 9, to go into the calculator, random norm can be found right where you did random integers. So you go to math and over to probability. Random norm, you type in 0.4, comma, 0.023, comma, 400, and then hit the store button and put it in L1. It will take a while to load, so if you see it loading and it hasn't came up yet, it'll take a little while. Then when you go to stat and hit sort A and do list 1, again, it will take a little while to load. So make sure you try those, and actually everybody's answer may be different, so you need to try it to see what you actually get for the probability. For number 10, you look at the chart there. You only get, for number 10, we're only looking at household probability and we're looking at family probability in part A. So in part A, it wants you to add up all the household probabilities, make sure they equal 1, show that on your paper. Then add up all the family probabilities, make sure they equal 1, show that on your paper. And then for part B, it says make probability histograms. That means for the first histogram, it'll be just household probability. The x-axis will just be the numbers 1 through 7, and the y-axis will be the probabilities, and you just make a histogram. And then for families, you do the same probability. The x-axis will be 1 through 7, the y-axis will be the probabilities, and we're going to compare those two. What do you see about both of them? Meaning, what about their shape do you notice, and what about where the median is and the average on those? For number 11, the size of the households, we're looking just at the households in part A. So what's the more than one person lives in the household? And that would be x is greater than 1. So add up all the household probabilities that are greater than 1 and see what you get. For part B, it says what's the probability that it's between 2 and 4? So it says greater than 2 and less than or equal to 4. So it includes 4. It doesn't include 2 because it was greater than 2, but less than or equal to 4. So that would be the probability that the household, probability for the household of 3 and 4. So you would add those two together. That's 0.17 plus 0.15. And then for part C, it says the probability that it's not 2. Well, if it's not 2, that's the 0.32. Remember, we're only looking at the top line for this problem. So 0.32, it can't be that one. So you'll add up the 1, 3, 4, 5, 6, and 7, which would be 0.25 plus 0.17 plus 0.15 plus 0.07 plus 0.03 plus 0.01. Number 12, car ownership. Verify it's a legitimate distribution. That means make sure they all add up to 1. And then draw the histogram. Again, your x-axis will be 0, 1, 2, 3, 4, and 5, and your y-axis will be the probabilities. Now, what in words does it mean that x is greater than or equal to 1? And I'll give you that. That means the probability that a household owns at least one car. So it's greater than or equal to 1. So the probability that they at least own one car, add those up, 1 through 5, and get those probabilities. And then in part C, a housing company builds houses with 2-car garages. What percent of households have more cars than the garage can hold? So which ones have more than 2 cars in their garage. What probability or what proportion of them have that? That's number 12. Number 13, the dice. Write down all 36 possible pairs. That means you could roll a 1-1, a 1-2, a 1-3, a 1-4, a 1-5, a 1-6, then start. A 2-1, a 2-2. Okay, so write down all 36 of those. What's the probability of each pair? Well, if there's 36 of them, they all should be equal to rolling. So that's your probability. Think of what that would be. Part C, define. It says the random variable x. We're talking about the sum. So the sum of the 2 dice could be any number between 2 and 12. And tell what's the probability of rolling a 2, what's the probability of rolling a 3, what's the probability of rolling a 4, what's the probability of rolling a 5, of rolling a 6, of rolling a 7, all the way up to 12. Okay, that takes you D, what's the probability of rolling a 7 or an 11? Add up the probability that you got of a 7 plus the probability you got of rolling an 11. Simplify it and give me the decimal there. And then what's the probability of not rolling a 7? That's 1 minus what the probability of rolling a 7 is. And that will give you the probability of not rolling a 7. Then we go to 14. This is a weird dice. The 1 is a normal die with 1, 2, 3, 4, 5, 6. The other die has 0, 0, 0, 6, 6, 6. And so here's how I set that up. I'll show you on the screen here. I'll set that one up looking like this for number 14. That's what you should draw. And if you look, your sums, they either add up when you roll the die, they either add up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, but there's an equal chance of each one. So there's an equal chance of rolling a 1, an equal chance of rolling a 2, an equal chance of rolling a 3, all the way up to 12. So what is the probability for rolling a number for each one? So I've kind of worked you through that one for number 14. So I hope, even though we kind of had to rush through this, I hope that you got something out of the video and that you better understand your probabilities and that you can go through that today. I wish you good luck on the homework, and I hope you'll do well. And I did look at your suggestions, and I will be working through those and trying to implement that and make this class as good as we can. We have 3 weeks until the end of the first 9 weeks, so I'd like to see the grades go up a little bit and see everybody learning and getting a little bit out of it. So don't forget, finish the first 6 online quizzes from the second edition, so we're caught up with that. That's 6 grades there. Make sure you turn in this homework. It'll all be 1 through 14 now that I've given you the stuff for 7 through 14. And we'll be ready for tomorrow's class. All right, thanks.